Good afternoon, everyone, and welcome to the Hydrogen and Fuel Cells Europe here at the Hannover Messe. We're here at the technical forum where we dive into all of the nitty-gritty technical details of the hydrogen industry. We're already at the last talk of today, and in the previous one we were talking about safety in hydrogen, and we'll continue on this topic. One of the most important things to ensure safety of systems, of products, is certification. And in this talk, we're gonna discuss certification of hydrogen technology-based products. We have not one, but two speakers on the stage for this last talk. We have Blue Energy Revolution with their member of the board of directors and their R&D project manager. Please give a warm welcome to Manuel Anselmo.
Thank you.
Welcome,
Hi.
Manuel.
Thanks.
And next to Manuel, we have another speaker. We have from 3P Safety, the product and safety consultant, Mr. Harman Jassal. Welcome, Harman.
Thank you. There you go.
Thank you. Thank you, everybody. Thank you, Arman, for staying on the stage with me. Thank you, Hydrogen and Fuel Cell Europe, for allowing us to talk about the certification of hydrogen technology-based products. So the aim of this presentation is to showcase some of our combined experience. We have Blue Energy Revolution from Italy. We are a company dealing with hydrogen technologies, in meaning electrolysis, meaning hydrogen storage, and meaning fuel cells. And we have 3P Safety, which has a lot of experience in the certification of this kind of technologies. So before we deep dive with Arman's speech in this topic, let me quickly introduce the projects from Blue Energy, because in our company, we don't simply deal with products, and you can see on the left here our container, our energy pack product, which will be discussed by Arman, but we deal with projects. So in recent years, we developed a 140 kilowatt PEM electrolyzer for a customer and installed it in the north of Italy, where you can still see it working. We developed a hydrogen boat, equipping it with our metal hydride storage units and a Nuvera fuel cell, which you can see on the top picture as well. We developed for Baglietto Yachts a laboratory in La Spezia, Italy, for the development of hydrogen boats. You can see the picture here on the right. And we started our activity back in the past years with Fincantieri with the fuel cell laboratory. So we come from projects, from developing custom technologies, and in recent years we came to have products. That's what we do. We gather the experience from the projects and from the hands on the technology to develop products to meet the customer demand. You see the container on the left, that's our energy pack. That's a hydrogen battery, allowing you to gather excess energy from renewables, store it in the form of hydrogen, and give it back by a fuel cell. You can see it at our stand A36. Within the container, there is our MOSE electrolyzer. We launched it here last year in 2024 on this stage as our new product, and we have already 5 units delivered within our customers and projects. And last but not least, starting from this year, we have a dryer solution dedicated for electrolyzers up to 120 kilowatt. So this just to show you projects and products from Blue Energy. Now let me leave the stage to Arman, who will talk about the certification of this product. Okay. Thank you.
Thank you, Manuel. Hi, everyone. So let's start to have a look on the projects that we have worked. So 3P Safety has a long history with hydrogen, dated back to 2005, when our CEO worked on the first H2 boat called Vaporetto, which is a typical boat from Venice. This was a project in collaboration with Eni, which I'm sure many of you know. And then we have worked also for Pietro Fiorentini to make a hydrogen laboratory where they test the products like valves and so on. We also work with, for hydrogen engine test rooms because there are a few companies that we cannot mention, fortunately, but they work on engines that use hydrogen as combustible. We also worked for Avuelle, which is a company that makes refueling stations. And in 2025, we are working for a 1 megawatt electrolyzer for Pietro Fiorentini, which is a company based in Italy. So as you can see, the common factor is hydrogen, but we touch many different sectors, from laboratory to test rooms to electrolyzer, etc. Here are a few companies that are our customers that we have worked on, and we're still collaborating with many of them. In the last 2 years, we have worked with Blue Energy. We have developed their first product, the Mose. The first challenge about this product was there are not too many specific norms and directives for the product based on hydrogen. And the first challenge that we have seen with the Mose for the ATEX zones, the input from the company was to make a product that was a standalone. That means it does not emit ATEX zone on the outside. This approach is completely different from what we see around. The company wanted to make a product that the end user had to only put in his place and install it without worrying about the safety features around his own product. Using the standard approach, following the EN 679 10.1, which gives the indication on how to classify the internal zones about products that use gas. In this approach, the Mose resulted to have a zone 2 inside, which means it has to, all the components have to necessarily respect the category 3G. Obviously, this method is based on all the considerations on the traditions on how all the plants were made in the past, but it also means you have to take in considerations all the other elements. In this case, we had to use a new approach based on the safety level, as we've seen from the previous intervention on pills. You have to integrate some safety features, so we have added an hydrogen sensor that gives two types of alarms. One is at 5% of the concentrations, and then at 50% it cuts down the power to the stack. Adding this sensor and managing the logics behind the safety features gave us the opportunity to declassify the internal zone of the machine, so it can be classified as zone 2 negligible. As you can see on the graph on the right side, you can see how the concentration of the hydrogens have a peak and then it decreases. That's because on the old approach, here, according to the EN 679, you hypothesize a failure, a leakage, and then you hypothesize it goes up in time for infinite time. In this case, cutting down the power of the stack, you basically stop the production of the hydrogen. So the quantity of hydrogen is very limited and it can be expelled outside from the fan that is positioned on the outside, on the upper side of the machine. So, so this approach combined with the ventilation of the inside of the machine and the use of the sensor and the logic, or the safety logic behind it, permitted us to declassify the internal side of the machine. So this was the first product. We also use the ISO 22734, which is for all the electrolyzer hydrogenerators using water electrolysis, because as Manuel said, their product use purified water, and then they use a stack with PEM technology, proton exchange membrane technology to produce electricity, to produce, the hydrogen. In this case, we also have a small amount of oxygen, which is not used, but it is expelled with the fan and the exhaust of the machine. In the end, the certification process is not done with the creation on the assembly of the machine, but you also have to make the declaration of conformity, where the company takes responsibility and indicates all the directives and the norms it have followed to certify the products, and also the user manual, where he gives the indication on the safety indication of the machine. The second product we have certified is the Dryber, which, as you can imagine from the name, it dries out the hydrogen from the particle of water you can have in the hydrogen. The working principle is very simple. You have two columns that have some elements inside it. When you put hydrogen, these elements try to trap the humidity, the water, and in the output you have a very dry hydrogen that can be used to be stored, or you can connect a fuel cell if you want, because the purity is very high. It is purity class 5, if I'm not mistaken. In this case, it's a new kind of product. Even in this case, we didn't have norms and directives to follow, so we have to use what we have, like machine directive, the ATEX directive, and also the PED, the pressure equipment directive. Differently from the MOSE, here we have a one step more of challenge, which is the pressure equipment directive, because we have some vessels, so allowing the internal volume and the pressure of the machine, we have to follow some strict rules, which indicates we have to follow a certain steps, we have to make a certain consideration, you have to make a certain type of risk assessment, and also you have to involve a notified body and an inspector that comes and check your products and give you the certificate of conformity. In this case, we used IWELD, which is an Italian certified noti body. It gives us the declaration of conformity correspondence about the PED, which indicates the category of PED and the safety features. Even in this case, we also have made the user manual, so with all the safety indications. So in these two cases, two different products, two different methods, and two different types of certifications. The next product that we are working from this year with Blue Energy, that Manuel briefly presented before, is the Energy Pack. It's a combination of these technologies. It's a combination of MOSE. It's a combination of the fuel cell. We use the PEM technology, so proton exchange membrane technology, and also use the metal hydrous, which is the accumulation of hydrogen. In this case, this product has been studied to have a scalability, so you can have 1 or 2 electrolyzers from 7 to 14 kilowatts, and in future it can also be implemented with the major and greater powers. You have the storage of hydrogen from 10 to 40 kilograms, which translates to 1 to 4 racks of storage. And these 4 racks gives an autonomy of 550 kilowatt hour. So this is the autonomy of this Energy Pack. And also you can install multiple fuel cells from 1 to 3 units to up to 13 kilowatts. Even in this case, you have to add the complexity, because Blue Energy enjoys to add a complexity to its products. In this case, the complexity is the scalability of the product and the combinations of these different types of technology put together in the use of the hydrogen. Even in this case, you have some inputs and some outputs. We can see here the 3D of the product you can see on my left. I have indicated the norms and the directive that were used for the first assessments. In this case, as we have seen on the driver, we have to protect the pressure equipment, the protection piping, the pressure circuit. We have to install an emergency vent. So the system in pressure, as per directive, has to be protected by the safety valve. For the electrolyzer and the fuel cell area, we have added the sensor that we have seen before with the MOSE, plus a fan. So this gives us the opportunity to declassify the ATEX zone, which translates to have a cheaper product because you don't have to use all the components certified as ATEX. And it also gives the opportunity to not have a classified area inside the product, inside the energy pack, other than the storage, the rack, because there you have the storage, you can declassify that zone. So these are the initial safety assessments that were made. As we've seen on the storage, which is the central part of the energy pack, it's zone 2, but even there we have made an exit point for eventual leakage of hydrogen. The energy pack in its whole can be divided in 4 zones, 4 major zones. We have the electrolyzer zones, we have the storage zones, we have the fuel cell zone, and we have the zone where we have the compressor, where we have the water treatment machine that gives the purity of water necessary to make all these machines function correctly. So as you can see, it's an integration of many technologies and many different types of machines. So what is the certification process followed for each type of machines, each type of products? And what are the applicable directives? Because we see many products, but we often don't know how to move, how to certify certain products, what is the correct procedure to certify the hydrogen-based products. So as you can see, it depends on how the product works, on what are the safety features installed on board on the machine. And for the same product, we can have a different type of certifications. In the case of Blue Energy, the MOSE, we have applied the machinery directive that everyone knows. We didn't apply the ATEX directive because it was not necessary, but we have made the classification, the internal classification of the machines. We have followed the norm EN 679, which gives the guidelines and how to classify correctly the risk, the concentration, etc., of the internal part of the machine. The pressure equipment directive does not apply fully because considering the pressures and the internal volume of the piping of the circuit, it falls under the Article 4.3 of the pressure equipment directive. For the driver, which is it seems the more simple products, in reality it was the more complex one because it was a certification combined of 3 different type of directives. We applied the machinery directives, the ATEX directives, because it can be installed in a classified zone, so it needs to be secured to be used in a classified zone. Pressure equipment directive, because as we have seen before, there was an involvement of a notified body, of an inspector, that gave us the certification needed. For the energy pack, the process is ongoing. We are halfway through, we are working on it. The first approach is to obviously you have to apply the machinery directive. The ATEX directive is not fully applicable. As we can see before, there are compartments inside the energy pack. So you cannot use the ATEX directive. And also the energy pack is designed to be installed on open space and do not emit itself an ATEX zone, a dangerous zone. And also the PED directive, it's under process. We are evaluating if it's fully applicable or not. As we said, the The project is ongoing. The scalability of the project is under evaluation, so we have to see if the PAD directive it can be applied fully or not. Thank you for attention, and if you have any question for me or for Manuel, if you want to come on stage.
Man.
Thank you.
Thank you very much, gentlemen. Are there any questions in the audience so far? No,
We had a
don't-
very short period of time to present the certification process because it required hours of, but we had to cut it very, very short to make it very, very simple. So if anyone have a question or if later on you can come to our booth.
Yeah, I can imagine it's quite a lengthy process. I used
It takes
to study.
months. It's not
Yeah,
hours.
yeah, exactly. I used to study aerospace engineering,
Okay.
and there they always said when the stack of paperwork is as big as the airplane, then you're getting close to certification. Is it a bit the same in the hydrogen industry,
Yeah,
or
almost,
is it?
almost.
That's true.
All right. Well, I'm glad you guys
Yeah.
are here then
Thank you.
to bear this burden, let's say, of certification and to make sure that all of these very nice products that we have here can actually be certified such that we can actually use them here in
Yeah,
Europe.
because
And-
everyone see the products, what they touch with hands, but they do not see the certification process the company has to undergo to certify a product to make it secure and safe to use for the end user, which is the ultimate goal to make a safe product.
Yeah, and it is our aim to communicate with this kind of intervention that the product is not finished with its performances. You know, you discuss, oh, this is the performance, this is the cost, but it's rather than the applicability you have. And this comes from the study of the technology and the safety and certification process.
Exactly. I couldn't say it better. Thank you very much.
Thank you.
And I would
See
say
you.
enjoy your evening and enjoy the rest of the fair.
Thank
Okay,
you.
thank
Bye,
you.
everybody.
Thank you. Thank you, everyone.